This video deals with why is the insertion length of a mag meter set to 1/8 the diameter. This is shown in the in these videos here. We explain how those are. Let me show you the math that tells why this sensor is put 1/8 of the diameter of the entire pipe. Here is the classical illustration. Diameter of the pipe, insert the sensor 1/8 the diameter so that is representative of the flow. Where does this come from? This comes from Miller fluid mechanics, but in laminar flow velocity, a lot of people get these mixed up. Laminar looks more like a bullet than does turbulent. And the reason for that is, and the reason for the flow profile is because of viscosity. If there were no viscosity, there'd be no flow profile. So you can imagine honey would look more like this and water would look more like that at the same velocity. But as the flow becomes turbulent and fully developed, it looks more like this. And notice that the shape is more flat, and the velocity, because this is actually parabolic, can be represented here. Here are some diagrams from Miller. This one describes laminar, and they're going to show that the max velocity. This is the max velocity here on this particular one. This is the max velocity, V max, and then there's the V total flow, the integral of the flow. So V max, or the actual flow, is half of the maximum flow in laminar. Here's if we were to derive what's the location of the mean flow, it's they say y bar equals 0.293 rp, and rp is d over 2, or 2d. So it's y bar equals 0.147, and y 1/8 is 125. But they're not talking about laminar flow. The flow in a pipe, if it's laminar, the folks who put the pipe together, they'll say, why did you put such a big pipe in there? You're not using the resources well. Use fully developed pipe flow. So that's what we're looking at, is fully developed turbulent pipe flow. And here are some of the equations. You could read this in Miller on your own. But let me show you where it comes from. In the end, they take these equations that have to do with the roughness of the pipe and all those good things. It all comes out to this little y bar over rp equals 10 to the 1.43 over blah, blah, blah. Y over rp equals 0.216. Y bar equals d times 0.216 over 2, or d times 0.108. And 108 is very close to 1/8. 1/8 is 125. So it's a rounding, so they don't have to say y bar equals 0.108 d. They say y bar equals 1/8 d, 0.125. It's close enough. It's better to be a little longer than shorter. It won't hurt you. But if you want to be a perfectionist, I would put your pipe right there at 0.12 at 108. And here is also another diagram that'll show y bar is 0.216. This is the radius, so you have to multiply that times 2 or do with a d. So y bar is approximately d over 8. So that is it, and enjoy. If you found this video interesting, please click like, and also you can look at the insertion mag meter. I mean, not the standard mag meter. Because the price of these things are relatively low, putting an insertion isn't really necessary since the prices are fairly low. The insertions are really good for the larger diameters, and when you want to take them out and review them. Here's some different types, and here are some of the requirements for inlet and outlet conditions. All flow meters want to have the flow treated well upstream and downstream. So there's 5 diameters, 3 diameters. Don't put mag meters in places where they're in front of pumps and do all these other bad things. You can watch the videos here and see how to set the displays of these and configure these mag meters. Thank you very much.